Good morning. Welcome to the O-Scope Wizard. I am Gabe, the O-Scope Wizard. It is Band Shirt Tuesday. I'm not wearing a band shirt, but I am wearing a punk shirt. I got a coworker named Neil, and this shirt was made specifically to let him know I need to beat Neil every chance I get. So, thank you for joining me in the Techno Lair. We're going to nerd out for about 20 minutes today. Luckily, oh, and chat, the bald engineer was wearing his Neil shirt too. If you have a Neil shirt, you should wear it and let people know that you need to beat Neil everywhere you go. There's a couple of Neil shirts in the wild. So, I have a timer today. I have been doing this show without a timer the last couple of times, and that is not a pro move. So, about 20 minutes hanging out in the Techno Lair together. I've hit record. I've hit stream. We're all live. We are working on making, ultimately, we're making a 5-gallon, we're making a subwoofer in a 5-gallon bucket. I call this my 5-gallon bucket sub. It is going to be hopefully wireless as it can be. And it is going to augment the sound in my driveway. Now, on the last show, we left it measuring a single RC filter. And we're working on filters because filtering the sound that goes into the subwoofer is pretty important because the subwoofer is all about low tones. We want that thing low. So, with that in mind, we were designing low-pass filters. I have on my desk right now a tiny little RC filter. It is a, let's see if I can even, I think I can even get this closer. I think I can move all my cameras as if I am a whole crew. There we go. We're getting closer. There we go. Right here, I have a 10K resistor, and right here, I have a 100, I think it's a 100 nanofarad capacitor, plus or minus 20%, because these little tiny ceramic caps I hear are terrible. And I have done a Bodie plot for that. And I love Bodie plots because they're a wonderful way to look at the relationship between V out and V in. And I just swept this Bodie plot. Here's my oscilloscope at the end of its sweep. And here is the actual Bodie plot. You can see that the signal went up and went down. Based on my calculations of this R and this C with a, let's close all my download. I've been working on some 3D printing. You probably can't even see. Can you see the 3D printing in the background? Let's see. Yeah, you can see the 3D printer in the background over my shoulder there. I'm working on trying to figure out how to 3D print, guys, and I'm not great at it. I'm making a whole bunch of bird's nests. There are going to be many plastic birds with lovely plastic nests in the near future. But back to RC filter calculations. So with my R and my C, I chose a 10 kilo ohm, 10 kilo ohm resistor, 10K resistor with a 100 nanofarad capacitor. The cutoff frequency is 1 over 2 times pi times R times C. It should be 159 hertz, thereabouts. But the big negative on using a passive filter is there is some loss. There is going to be a loss in the gain. So instead of the whole signal getting through, you're going to lose a little bit of voltage. So you're going to get only 0.707 is going to be your gain. So you would take V in times 0.707 equals V out. That would be your gain. Loss in the gain, less gain, less gain. There's going to be less gain, loss. I think that, you know what? I'm saying that wrong. There's going to be some loss through your RC filter. Not gain, not gain. That's the big negative of passive filters. There is loss through the passive filter. And what I wanted to do today, so we were talking about first order filter. So this is just one R and one C makes a first order filter. What does that mean? That means that this line this slope right here where the signal rolls off, it rolls off at 20 dB per decade. So from, 100 hertz to 1000 hertz, it would drop about 20 dB if it's on its regular slope, and you can see it's continuing down. And I would like a sharper slope, a steeper slope. Why do you want a steeper slope? Because that filters out more of the high frequencies quicker so that they don't get into your subwoofer. You don't want your subwoofer to be trying to play high trumpet sounds. You want it to be playing that sub bass, that 808 kick. That's what we're looking for. And that mostly sits around 150 hertz and below. And I don't really want anything above 150 hertz going into my subwoofer. So the steeper of a slope, the fewer of those high frequencies. The steeper the slope, the fewer high frequencies make it into the subwoofer, and the subwoofer should sound better. So in order to increase this slope, to make this line steeper, using passive filters, I can string together more R's and more C's. So you know what I could do right now is I can rerun this test really quickly and have my speaker connected. I'm going to connect my speaker up. And I have added a couple of handy dandy little test cables to my speaker so it lets me plug it in. By the way, over the weekend, I managed to blow up my other audio amplifier I was working with. That was kind of a bummer. I have a real tendency of blowing things up. It was working. I was working on an active filter network to replace the passive filter network. And I think I got a little bit aggressive with the gain and ended up blowing my speaker up, which was sort of a bummer. It happens, though. It happens, guys. It happens. Now, what do I want to do? I want to take this speaker. I'm going to hold it in my lap so that we can hear it, hopefully, while this Bodhi plot runs. And then we're going to try to do a multi-order filter. I want to do a third order filter. What am I trying to say? Third order filter. So let's run this Bodhi plot again. Get the scope right there so we can see some of the signals in the background. Let's run it. Boom. Can we hear it? Ooh, I can. Ooh. Kind of loud. So, we could hear the you may not have been able to hear it. I could hear the high frequencies. Could I don't know. Can you hear the high frequencies through the microphone? I don't know if you can. I got the subwoofer pointed at the microphone. I don't know if you can hear the high frequencies. I can hear the high frequencies, and I want to hear no high frequencies in my subwoofer. So what can I do? I could make a multi-order RC filter. So I'm going to try to set up a third order. So the calculations on this website, which I really like this website, talking about first order, second order filters. It's electronicstutorials.ws. I've gone to it a number of times on these episodes. If I do a third order, it shouldn't be 20 dB per decade or 40 dB per decade. It should roll off at 60 dB per decade. And I can calculate what the F and the C is using this little formula right here. So I can go 1 over 2 times pi times the square root of all my R's and C's. And as luck would have it, I actually have that down below. So one formula down here for the third order filtering, and one formula up here for the first order filtering. Let's delete this so we can see them all on the same screen. Now, the cutoff frequency from our first order filter was 159 hertz, which I like. Does that match the measurement data? That's a good question. The measurement data peaked out at about, if I go over to my table, the measurement data peaked out at 8 dB of gain. So if I subtract 3 from 8, that's 5-ish. It is not cutting off at 159 hertz. It is cutting off at 200 hertz, 219 hertz. Now, that could be because my R or my C is not actually 10K. You know what I can do really quickly? Let's measure the R and see if that is actually a 10K resistor. So I'm going to look back over here. Let's go back up a little bit so that we can see. There we go. Can we see my multimeter? Here's my multimeter. I'm going to take my, follow me to freedom. I'm going to take this R. Chat never said if they could hear the signal coming through, or the sound coming through the subwoofer. And I was really curious. Can you hear the signal coming through the subwoofer through my headphones or through my microphone? Not through my headphones. Okay, so this is supposed to be a 10K resistor. I'm measuring ohms. Plug it in. What are we measuring? 9.87K. Okay. If I go back to my formula, instead of 10K, you know what? You guys probably can't see this too good. So let me zoom in a little bit so we can see it a little bit better. If I say this is not 10K, this is 9.87K. So that's 9.87K. Okay, now I'm at 161 hertz. And what if that capacitor is not actually 100 nanofarads? What if it's only 80 nanofarads or something smaller? Now I'm starting to see my cutoff frequency jump up to 200 hertz instead of 159. Oh, this is what happens when simulation doesn't match your measurements exactly. So I think I'm going to trust my measurement. Always trust your measurements. If your simulations don't match your measurement, it's probably because your simulation is wrong. That is very common. So my first order filter is about 200 hertz. It was we were shooting for 159 hertz. So I'm going to set this back to what we were shooting for. So I mean, let's keep our goals. Let's keep our goals. Let's don't capitulate on our goals right away. And we're having some loss through that first order filter. So 0.707 instead of, it doesn't pass the whole signal. Now, if I do third order filter, oh, I have loss of 0.035. So only a third of the signal is getting through this third order filter. But can we design this third order filter to actually have a cutoff frequency of roughly 149 hertz and have a sharper slope? So what I'm going to do here is I think that I can save this particular waveform to memory 1. And I want to design this third order filter really quickly and put it in memory 2 and do some compare and contrast. Let's build the filter up. What are my R's and my C's that I was showing here? My R's and my C's: 330 ohms, 330 ohms, and 100 ohms. And I need basically 3 RC filters in order. Do I have a picture of what I'm trying to build? We're about to have the actual thing we're building. Let's see. Oh yeah, right here. So I'm gonna build 3 RC filters in a row. Hopefully you guys are following along. It's very exciting. You know, we're gonna do all this work and then realize that we probably should have just done digital signal processing from the get-go. I don't know. It's fun. I like working with little analog components though. Oop. All right, so you can see my board now, and I have these 47 microfarad capacitors. 3 of them. Let's make my R's and my C's. So here's the first C. And here is a 330 ohm resistor. We can actually measure it with my multimeter here, and we'll see how close to 330 ohms it actually is. All right, let's see how close it actually is. Wait a second. This is orange, orange, orange. Guys, orange, 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 orange is 33K. I need orange, orange, brown. The resistor codes. I always keep one handy by my desk. Orange, orange, brown. Orange, orange, orange is the tasty. Orange. Orange is my favorite color. I mean, I love orange. I love orange Fanta. I love orange shirts. I love all kinds of orange. My leads are giving me all kinds of troubles. What have I done to my leads? I don't know what I did to my leads for my multimeter, but watch. If I turn this on, I have my resistor plugged in. Will it do it? Oh, now it's happy. 338 ohms. That's pretty good. 338 ohms. That is a solid resistor. So I've noticed that the last bit of toothpaste that comes out of the toothpaste tube is not as minty as the first bit of toothpaste that comes out of the toothpaste tube. Am I crazy? Is that true? I think that's true. And I also noticed that I don't have ground connected to this rail. So I need to drop in a little wire so I have ground connected. I think that's true though. I think the last bit of toothpaste in the toothpaste tube is not it's not as minty. What do you guys think? Have y'all noticed this behavior? I mean, to the point where if I'm close to the end of a toothpaste tube, I'll throw it away because I feel like I'm just not getting that minty fresh feeling in my mouth. I don't want that. That's trash. It's frustrating to me. Why can't the entire toothpaste tube have the same amount of mint? All right, that's R2. I've been thinking about that. I meant to bring it up a couple of other times on the stream because I wondered if I was the only one who had noticed it. I also wondered if it was like a weird conspiracy amongst toothpaste manufacturers to try to like wiggle out of their last bit of mint commitment. Like we committed to a certain amount of mintiness, and at the end, we are within tolerances. We are plus or minus 20% of the mintiness guaranteed. How do you measure mintiness? I can tell. Oh my goodness. Chocolate flavored toothpaste. Oh, you know, so I was in Where was I? In Spain, maybe? And they had, is it licorice flavored toothpaste? Licorice flavored toothpaste? Now, I love licorice, and I know it is a very divisive flavor for whatever reason. Did I just put in the wrong resistor because I was yammering? Oh my gosh. I put in 1 microfarad and I wanted 47 microfarad capacitor. I said resistor and I meant capacitor. Anyway, licorice flavored toothpaste is for real. It's serious. It is. Chocolate flavored toothpaste. I like it. I like it. That does solve the problem. Who cares about the mintiness at the end? I just like the extreme mint flavor of my toothpaste. Okay. Third order filter right here. So RC, RC, RC. Does it follow our guess? So I need to wire it up. I need to take V in, V out, move them around. So here is my input voltage right here. And this is going to be the output of my filter that is going to go through my audio amplifier to my probe and to my speaker right here. So I'm going to run this again. Hopefully it saves the memory. Please save the memory. Let's run my Bode plot. Bode plot with a third order filter. Run the test. Okay, it did save it at least. And in the background, you can see my signals are getting through. Uh-oh. Might have gotten a little bit overly aggressive. Did I get too aggressive with my filter here? Oh, not much got through. Oh, but look, that slope is super steep. It's like steep beyond belief. Oh, so multiple orders did filter it more. I messed that up though. Let's see. Chat says the components separate in the package over time. The compounds separate in the package over time. Ooh, ooh. So inside, this is toothpaste. This isn't electrical engineering. This is toothpaste, guys. Guys, the components separate in the toothpaste tubes over time. You know what I do though? On the edge of my counter, I take the tube and just I run it along the edge to get the last little bit. Oh my gosh. Oh my gosh. Oh my gosh. Hold on.
5 minutes remaining.
Anyway, so what I was saying, 5 minutes remaining. Let's do 5 minutes so we stay on track. 5 minutes remaining. The last bit of the toothpaste, I rub along the edge of my counter to get it out. So maybe you know what? Maybe my toothpaste expectations are just too high. They're just too high. It's it's out of control. Back to Bode plots really quickly. The chat, continue your discussions of toothpaste because it is pretty exciting, and it is something that we need to discuss. It's a thing that needs to be examined. Really, honestly, guys. Where are we at? So if I started out at -2 and I go to -5, I already feel like I'm on my slope at this point. And 14 hertz. 14 hertz. You know what? If I have all my R's and my C's calculated correctly, I would expect 149 hertz, but I'm getting 14 hertz. I'll tell you what, it feels like I've got a power of 10 missing somewhere. 100. Cut the bottom of the tube. Cut the bottom of the tube. But then that would be your last squirt. If you cut the bottom of the tube with toothpaste, I mean, you have really committed to like, I am done with this tube. And I just always feel like, it just feels like there's always a little bit more toothpaste to be had. You know, just like one little bit. I'll fight toothpaste out of an empty tube for a good 2 weeks. What most would probably consider an empty tube. Hmm. What have I messed up here? Let me check. Let me check the board components because I have messed something up. All right, let's disconnect my amplifier so I don't blow out somebody's ears. Mine. By somebody, I mean me. All right, so is this 47 microfarad? So this is 47 microfarad. You probably can't see it. I can see it. Oh, you can see a 47 in there. 47 microfarad. 47 microfarad. That's a 47. Is this a 47? That's a 47. Where's my, how am I off by power of 10? All right, so orange, orange, brown, 330 ohms. Orange, orange, brown, brown, black, brown. That should be 100 ohms if I'm not mistaken. Am I right? Brown, black, brown, 100. Verify the resistors. Oh my goodness. We're getting some good advice in here. Getting some good advice. Let's verify this resistor. All right. This one says, all right. All right. Hold on. Hold on. Get your life right, multimeter. This is kind of making me think I might need a new multimeter, guys. 102. 102.5. 102.5. I mean, I'm going to just add that into my calculation right here. You guys don't have to worry about it. Make a note, 102.5. Have I wired it up? I think I've wired it up correctly. Would be the other thing. All right, now 330. 330. Come on, come on, get it. 331. It was 331. I'm going to write that down. You know what? It could be. Oh, 335. Whoa. No, 330. 332.1. Whoa. All right. 332.1. Might as well measure the caps too. With this little thing right here. Oh, that's a good idea. Oh my gosh. Oh my gosh. Where am I at? Where am I at here? Let me go back here. Chat says I might as well measure the caps too. And I just realized that my multimeter has a measurement for capacitors. So I'll tell you what, I'm going to measure the rest of my resistors and capacitors. I'll put it in the show notes, how it turned out. See if I can get this third order thing to work because it's 14 hertz and it should be 147 hertz. So I'm way off there. And on the next episode, we are going to try to do all of this again more quickly with some op amps I got. We're going to try, let's see, I got the TL072 op amp. It's just a basic bog standard op amp. I want to try to overcome the loss. So we were talking about getting loss through my passive filters, and every stage that I add to my filter, I get a little bit more loss. And I should be able to overcome the loss with this op amp. It should add gain. And then I'll have like a proper, like for real grown up actual preamp stage. You know, I'm pretty excited. We'll see if this guy works. I have another op amp on my board right now, but it's like an audio specific op amp. Let me see, the number is LM386, and it has 20 dB of gain fixed. You can't go below that, and I don't think I need that much gain. I'm thinking, like unity gain might be enough if I can just get the signal to my audio amplifier, which is actually going to be doing the amplification. We'll find out. Op amps, very exciting, very exciting. I'm not great at them. I'm sure we will blow some up. I bought 1, 2, 3, 4, 5. Hopefully I don't blow up 5, but I might. So I don't know all the nodes in the world. Nerds, I don't know all the nodes in the world, or nerds. I don't know it. I don't know that many nodes. I don't know all the nerds in the world. So please share this with a nerd in your life, and I will hang out and chat and see you guys. You know what? Tomorrow afternoon is a special episode. Tomorrow afternoon, because we're pushing forward, because I want to do these op amp experiments. See you guys later. Bye.